Hello and welcome to Rudy's Electronics Lab. I'm quite excited about today's episode. I already wanted to make this for quite some time. I already made a couple of videos about the REL CMU200 as a generic purpose type of instrument, but today I really want to talk about using it for the purpose that the device was originally intended for, a mobile radio telecommunications tester. The CMU200 is originally devised for application like in the laboratory, as you see in the left, or for production testing, where you would actually test each of the phones that are being produced, whether it's meeting its specification, as you see in the picture on the right. And I already got a test setup here. I got an oscilloscope in which I can see the spectral content of both the base station with the CMU is and a mobile phone. I got an oscilloscope here in which I can see the I and Q patterns in both directions, and quite importantly I got a mobile phone as well. And as you might notice, there's a bit of an echo here. If I move a little bit closer you might hear it. Hello?
Hello?
Test 1.
Test 1.
So we're actually right now having a phone call between the CMU and the mobile phone I'm having right here. Now let me turn off for a moment here this echo sound, because it is like very annoying. Yeah, the loudspeaker of the phone is turned off now. So what does it take basically to do the type of testing that I'm going to demonstrate today? On the CMU you need the GSM protocol. Well, basically I think all CMUs have that, but you also need the signaling version of it. There's a non-signaling and a signaling version, and the non-signaling version is for testing like amplifiers, filters and etc. But the signaling version is really testing a fully equipped mobile phone. So it also tests like all the protocols of registering to the network, setting up a call in the network, sending and receiving SMS messages, etc. And actually we're going to do all of that today. So that's what you need on the side of the CMU. What you're also going to need is a special SIM card. A regular type of SIM card will not work, the one that you will have probably in your phone yourself. That is likely because of the security protocols, A3, A5, A9 if I remember well of GSM. I don't think they're implemented in the CMU. Whatever case, you need a special test SIM card. And it took me a while to get one. And to find somebody who was actually willing to ship me just, one or two of them. Eventually I found a source on eBay where I could order just one, and I got it here, and it's written CMU200 on the paper that they send it in, but it doesn't work. And I contacted them several times and they never even replied to me, and I think it's kind of a fraud, so I recommend you not to go to this seller on eBay. Eventually I ended up buying it from a seller that was willing to ship a minimum quantity of 20 cards. So I got 20 of these type of test SIM cards here. That's a bit much, but then again it serves me pretty well, because I've been trying this with at least half a dozen of different phones, so it was rather convenient, so I could put SIM cards in each of all of these phones here. I think to fully appreciate today's episode, you will want to have some basic knowledge about how the GSM protocol works, the physical layer protocol. So I decided to add in a crash course of less than 1 minute basically about the GSM protocol. But if you already know all of that, then of course you can skip it and you can fast forward right away to the measurement section of this video, where we're actually going to be setting up calls with a GSM terminal. A quick introduction into the original GSM protocols, focusing here on the physical layer mostly. And there we have different frequency bands for the uplink and the downlink communication. The uplink communication is from the mobile phone to the network. The downlink communication is from the network to the mobile phone. And since the uplink by the mobile phone was considered to be the most delicate in terms of attenuation, it's given the most attractive band, which is the lower frequency band. Now, These two pieces of bandwidth, 25 megahertz each, are divided into channels, 124 channels to be precisely, and each of them 200 kilohertz wide. And each individual channel in the downlink and the uplink are spaced exactly 45 megahertz. So that is the so-called duplex spacing within the GSM protocol. So now what is happening within each of these channels? Well, different users can use the networks within one given channel by giving them different slices in time, so TDMA. And we see that over here, for example, for the downlink. In the downlink we have 8 time slots which can be allocated for traffic of different users. A time slot is 580 microseconds, and a whole frame consisting of 8 time slots is 4.6 milliseconds, and then the whole thing repeats itself. You have a similar type of time slot structure for the uplink. There the time slots are shifted a little bit, so they're not taking place in the same moment in time. And if we would focus on one individual mobile phone communicating, we would see something like this. It would use some time slots to measure the network. It would use some time slots to receive voice information, some idle time. It would use a time slot to send information, and it would use some period again to measure and maybe also measure adjacent cells and other stuff. Now there's a very sophisticated protocol by which the network communicates with the mobile phone, for example, to set up a call. And you see an example here. This is setting up a call on the initiative of the network. So what you see here, that the network is paging a mobile phone, then all types of messages are going up and down, and eventually a traffic channel for voice communication is set up. We don't need to go through all of this, but for my further experimenting, I would like you to remember just 2 terms. One of them is the BCCH, which is the broadcast control channel. That is a channel with all type of information being broadcasted relevant for the mobile phones in the network. And it's the TCH, which is the traffic channel, and that's actually the channel where a voice call is taking place in. And in this case, it's a so-called F channel for the full rate vocoder, not the later half rate vocoder used in GSM. Now, before I'm turning on my CMU, I first want to make sure that I am not disturbing anybody. And to be honest, the CMU is going to send out really low signals, and the phone is also going to turn down basically its power because it got like a dynamic power setting. So it actually even doesn't work if we move it more than, I think, half a meter away from the antenna that are connected to the CMU. But nevertheless, we want to be good people and we want to make sure that we're not disturbing anybody in the GSM spectrum. So right here I'm looking at the GSM spectrum on my spectrum analyzer. And on the spectrum analyzer there's a nice functionality that you can actually make it show different channels for a particular standard. So that's what I already said with GSM. I have basically set the spectrum analyzer to show channel 62 right in the middle. Why 62? Well, we got 124 channels, so 62 should be exactly the middle of the GSM spectrum. And my span is 25 megahertz, which is exactly the bandwidth of the downlink. And of course I'm interested in downlink signals here, where there's any operator working here. I see some activity going on here. I see what seems to be a bit of a broader band. So I think somebody has been kind of refarming the spectrum and using maybe some 3 or 4G signal there. There are some smaller carriers, maybe these are still old GSM carriers going on. In order to get a better view of what's going on in the spectrum, I will basically put my device on maximum hold, in which I'll just get to see what power has been sent out up to now. And now I see much nicer. I got a relatively broad signal here, maybe LTE, haven't checked it out. That could be 5 megahertz or 3.8 megahertz. I got also a bit of a wider signal here, at least wider than GSM. I got a couple of signals here that might be GSM signals. Obviously I want to sit somewhere in a completely quiet space. So we see a number of quiet spaces here in the spectrum. I want to choose some spaces that are sufficiently apart. That makes my work a little bit easier to see in a moment. So I'm going to choose one thing over here, I already checked it a little bit previously to this video, but if I will be taking channel 90, you see here we go to the middle of the spectrum analyzer screen. We will be in a quiet area. I'm going back to the middle view, and I'm also going to pick a little bit here in a quiet spectrum over there. So I already figured out that channel 45 actually might be a good one to go to. So let me go to channel 45, and you see there, we're between some other signals, but also right there, nobody is currently sending any power on that particular signal. So now we've kind of decided where we want the CMU to send out its signals. Now the next step basically will be to set up the CMU for our job today. So we go to the menu, select, choose GSM 900, and of course we're going to choose signaling because we're going to work with a mobile phone. So there's going to be like the usual protocol informing the mobile phone what to do, whatever. So that will be GSM 900, and I'm going down to that menu, and I'm turning my signal off for the time being. Now I'm going to set a couple of different things here to get going, and most importantly, I'm going to go to the base station, and I'm going to first set the channels that we want to be using. So for the traffic channel part, basically, I'm going to choose one of the channels I just identified. That's going to be 45. Sorry, for the signaling part, and for the actual voice calls, I'm going to choose the other channel that I just located, which is going to be channel 90 there. Did I make a mistake? No, that's fine. Now with very low power levels, actually this is mostly used, this type of configuration, to connect this with a wire directly to the RF port of the phone. But you can also use it basically using open air antennas and very specific environments even. You can even buy them from Roden and Schwartz. But I'll be just using a relatively simple antenna, and I'll be just I'm changing the back to channel 45 here. Sorry, I'm changing the wrong value. So I'll be just cranking up the value to minus 10 dB, which is still considerably lower than 1 milliwatt, just to be sure. And also here, let me just make sure I go to the right menu, and also the traffic channel I'm going to put at minus 10. So that looks good. Maybe I should have mentioned I've just been resetting the Roden and Schwartz as well. The other thing I want to do is go into the network settings, and I want to choose a network identity so I can just recognize which network I'm working from. We got a mobile country code and we got mobile network code. I'm going to choose a mobile network code, something I haven't used before. Let me choose just 66 as a mobile network code. So in a moment the phone might recognize basically this as the network that it wants to lock itself to. And finally, because I want to see some IQ signal here as well, I'll go to the IQ manager here, and I'll tell basically the system to send out any IQ signal, but bypassing basically the system. So not interrupting any signal, but I'm just monitoring the signal. I think I'm kind of ready to turn on the CMU now. So I'm going back here to the mobile control menu, and I'm going to turn the signals off of the CMU. And we directly see here that we are generating some signals in the spectrum here. Things are going on, and actually if I start looking at my IQ diagram, and I will do a little bit more of that in more detail in a moment, we will actually see things going on there. Now let's investigate the IQ signal anyway. So this is the IQ signal of the CMU that is working as a base station. This will be the IQ signal of the mobile phone, but that's still turned off. As you might already realize here, this signal here might be kind of hard to trigger to, even if we notice that sometimes there's some action going on in some time slots and no action in other time slots. How I'm synchronizing it, basically I'm deriving that from some signals that come out here of the the connector auxiliary 3, which is right here on the front, which offers me several synchronization signals. And I've actually led them here to the scope, to the digital channels, and I'm here triggering on one of these channels here. So this is kind of, yeah, probably time slot 0 reference here. Here comes time slot 0 again, so it seems like time slot 5 or 6 or so has some varying signals here. So that must be the signaling part, the BCCH type of information, and the rest of the slots for now are sending out signals, but they're not varying. They're constant type of codes. If you look very well, maybe I'm going to zoom in a little bit later on, and we also see here that part that is changing that time slot. In the middle of it, it got some fixed portion to it. So that is the channel training code here, which is in the middle of a burst. But we're not going to go into details right now. Of course, I would love to see if the phone is doing something. And I already told you that we're seeing 2 signals now basically at the spectrum analyzer, but I would rather see the whole range, including the downlink here. So even better, I'm going to set the spectrum analyzer to see the entire GSM band, uplink plus downlink. So that will basically start at 890 megahertz and should be ending at 960 megahertz. Yeah, so here we got the downlink signal, and here we should be seeing the uplink signal. And now I'm going to put some markers where I would expect the action to be going on. So in terms of the downlink, I expect to see some action basically at the channel 45. So we can look that up, and that's 944 megahertz. We already see a strong signal there. I'm also going to put a marker at channel 90, so that is 953. So channel 2 going to be at 953, sorry. So there should be a second marker. Oh, that is just beyond what I'm just at the end of what I'm seeing here. I actually might want to increase the range a little bit. It's just at the right end of the GSM spectrum. And I'm going to be expecting some traffic here basically back from the mobile, and that was going to be at channel 90. So 90 downlink. So 90 uplink should be 908. So I'm going to put another marker at 908 here. Let me just have the total stop frequency a little bit beyond there, 970. So it will be a little bit easier to see my markers here. Yeah, so there we go. So we got here all the markers set. Oh, I must have made a mistake in marker number 3, because I'm number 908. I see it's set at not at the absolute frequency, but it's set at a relative frequency. So I'm going to put it at channel 90, which should be 908. Okay, so we got basically a signaling channel. We got a traffic channel here from the network. And we got here the traffic channel basically from the mobile phone that we should be appearing later on. And that should be like 45 megahertz because of the duplex spacing. Now that's, I think, about time to try the mobile phone. So here we go. I'm going to turn on the phone. Select operator. So the phone is searching a network now. So let's wait. I set a network code of 66, I believe, so let's wait for 66 to be coming in. Okay, there we go, and so we see a 2G network basically, 66 available there. So I'm going to tell the phone basically to try to register to that network. Look, selected operator 66. So now we basically got it connected here, and here on our device. We also got a different signal. He's now not waiting for a phone to synchronize, but he tells us now ready to make a a phone call here. And what we also see here is that the mobile phone actually started to get active. It's sending some signaling information. So it has sent some information which is called the location update in GSM to know about its presence and everything. And so we saw that coming in here on the spectrum analyzer. I'm going to keep the spectrum analyzer here at keeping the maximum value, so we see kind of new things going on. So what is the first thing we're going to try here? Well, let's try a mobile phone call from the network to the mobile phone. So here we go. Connect the mobile. Paging in process, we see. So it's trying to send up a page signal. And on the phone. And I accepted the call to the mobile phone. There are a couple of things going on right now. First of all, we are actually seeing the mobile phone IQ signal, which is then received by the CMU. And we can see that it is happening in another time slot than the base station. So at the base station, basically, we now see it is actually sending signals in two different time slots. So there will be one of them will be signaling information, and the other one will actually be the call, because we're making a phone call right now. And here we basically got here the phone call going on, and alternating. There's also going to be some signaling information sent by the mobile. Now, just to make sure that this is a real phone call, I'm going to go to my phone and I'm going to try to put it on exit. Sorry, I'm not. I'm going to put it on the loudspeaker. And I'm going to move my microphone a little bit. And what you can see now is that the CMU is actually sending an echo. Yeah, so that makes it kind of convenient. We can also set the CMU to auto mode, that it actually sends a pseudo-random bit signal or other stuff. I'm going to turn this off right now. This is very annoying. Yeah, I turned the external loudspeaker off, so the signal is much lower now. So we can also set the CMU basically to set a random bit, pseudo-random bit sequence, other things. But I'm mostly using the echoing myself, because that's an easy way basically to check if the device is doing what it should. Now, a couple of more things that are kind of worth exploring, I think, at the side of the CMU here is, first of all, some information by the mobile phone. So the mobile phone has been informing us about a number of things here. And one of them, for example, is the frequency bands that the phone can operate in, and also the power levels at which it can operate in within these frequency bands. Yeah, then the next thing we can do, and then we actually get to the whole measurement domain here. We go out of the connection control, and I'm not going to go in great detail here, but these are all types of connection measurements that actually can be performed on the mobile phone. So this is an overview of connection. There's always like a number of different applications running here. We can take a little bit at the transmit power. So here we see basically whether the transmitted power stays within the power envelope, especially also at the start and the end of the burst. So it must all satisfy this basically to meet the standard here. We can see some stuff here about modulation, and again the multiple kind of analysis we can be doing here. Also on 8ps key, but phase key shifting. But now we're basically skipping to the voice call in GMSK type of modulation. And we can see here the spectral mask, whether the phone is satisfying in terms that the power that is being transmitted stays within the mask. Now there's really a lot of other menus here, and it goes way beyond the scope of this video to go into detail here. So I'm just going to leave it at that to give you a glimpse. I want to do one more thing here basically, and that is actually to test the phone also to send SMS messages. We can also do that, and GSM also supports sending SMS messages during a call. So yeah, why don't we try that? So I can say send SMS, and the SMS is intending to send says, the quick brown fox jumps over the lazy dog. That is a preset message. Well, okay, whatever. I'm just going to send that message by pressing enter here. I'm going to look at my phone. oh, one new message received from 12345. View the message, and we see actually the message coming in, like the quick brown fox jumps over the lazy dog. So that works all right. So I can actually send a message back, and I can say something like, thank you. Let me see if I can still master. I think it was called the T7 thing to send messages. Wait, T7, T8. Oh, I'm still pretty good at it. Thank you. That's actually quite, it works still quite well as a mass messaging. Yeah, cool. I sent a message back. It's a little bit slow because we're right now into a phone call. And it sent the message, thank you. Yes, there are two more things I would like to show you. And as you might notice in the measurement setup, I've replaced the Roden & Schwarz for the Keysight scope. The reason I think it does a better job at showing fastly changing signals. So I prefer it for that. So we can take a better look basically at the time slots. Now let's do that right away. And we can see here very nicely how we have like a preamble and like a fixed part in this signal here. Do you see that? Here we got the fixed part, and here we got the changing data signal. Yeah, very, very nice. There is one more other interesting thing to explore here. If we look at the signals of the mobile phone and we zoom out, we would see here that they're not constant. There is a gap. Once in a while there's actually a missing time slot. This is actually built into the GSM design, that once in a while a mobile terminal needs some time to listen to adjacent cells, and while doing that basically it does not send the data. So that is a deliberate gap in the transmit sequence of the mobile phone. It's again connected via the same syncing signal coming from the Roden & Schwarz. Of course, it wouldn't be too hard to sync on those, but I'll show you in a second why I am actually doing that. Now, the two things I actually want to quickly look at you, and let me just move to the other side of the measurement setup, is actually the time slot settings. I'm returning here to Mobile Connect. So one of the things basically we can do is tell the mobile on which time slot is supposed to operate. So we'll do that. Now it's at time slot 3 and I go to time slot 4. And I think you saw a movement of the time slot where the mobile is actually sending. And we go to time slot 5. And again, it goes to time slot 5 and to 6, etc. So we can really see the time slot in which the mobile is operating, and this is the reason why I'm using this external sync signal, because otherwise you would just trigger on the beginning of the slot and we would not actually see that the slot actually is in a different position in time. I cannot choose all the different time slots, basically only 2 to 6, because some of them basically the mobile, remember what I told earlier, needs to listen to the network, so we don't have a total choice. Now the final thing that I would like to look at right now is frequency hopping, which was a feature that was in GSM right away from the beginning, and one of the features that actually made it a more powerful telecom system than other systems, by quickly hopping through a whole range of predetermined frequency patterns, etc. It could basically level out any errors that like specific fading, for example, multipath fading, being there at one specific frequency. So you average out a little bit. So it can basically jump from one frequency to the other continuously, basically per slot or so, or per frame, I would say. And we can actually do that as well with the CMU. We can turn on the hopping sequence. We can choose a sequence A. And what we see happening right now is that the phone call actually still works. I can still hear it. But we basically see on the spectrum analyzer that is going all over the place, both in terms of where the network, the CMU, is sending signals and where the mobile is sending signals. So this is a very nice illustration of the frequency hopping property of GSM. One of my viewers recently also asked me whether it was possible to compose your own SMS messages, and actually that is possible. If we choose send an SMS message, it comes up with basically of the default message, but you can change that. You can change it on the device. That is a heck of a job. I'd rather take like the external keyboard, USB keyboard to do that. So to do that, it's a bit of cumbersome. I need to press this button and I'll delete all of the existing text here. And there we go, and I'll type something else. Rudy's Electronics Lab. And basically enter. That should send. And on the phone we see it waking up. We go to messages. So we go to the phone and we open up messages. Conversations, I think. Yeah, and the top message, as you can see here, says Rudy Electronics Lab, as I just type on the CMU. So altogether, I think this kind of nicely demonstrated the way in which you can use the CMU as a testing device for GSM. Now that brings us almost to the end of this episode. A few final words. So first of all, the CMU can also do testing on other types of protocol, most notably 3G wideband CDMA, also known as a UMTS. It can do a bunch of other protocol like CDMA1 and CDMA200. It can also do Bluetooth testing, which is not a cellular system. I haven't tested any of these right now. I might get into that in the future. I did some initial tests with wideband CDMA. They didn't work yet, so I might need to figure out a couple of things. The other thing that I wanted to mention is the testing I did today, I did it with a Nokia mobile phone. I think the thing is called the C2 phone. I got the box still right over here. So that worked well. But my testing didn't work with every phone that I tried, and I want to give that message with you. Originally, actually, I was planning to do this episode with a really unique type of phone. This looks actually like the former flagship model, one of the earliest flagship models of Ericsson. Actually, this phone isn't. It is branded Sharp, but it is made in Sweden. And I believe this was one of the phones where Japanese manufacturers could not obtain licenses for the patents required for GSM. And actually were bringing some rebranded phones of other makers on the market. It doesn't work because it tries to send a location update which is not accepted by the CMU. And so it cannot register into the network. I'm pretty sure it's actually something broke in this phone in itself. I also got this other slightly later Ericsson model here. I bought it second hand for a couple of euros, but unfortunately the SIM card reader is broken, so that's not going to work either. Then I had a whole bunch of GSM phones that work perfectly fine. My favorite of all times, let me keep it here. This is the Motorola Razr V3. It's not the third version. I think the first one was called V3. An absolutely gorgeous phone in a metal housing and very innovative, by the way. They already removed the headphone socket and replaced it by USB. I mean, Apple got that idea only much later than Motorola. What also worked well, I got some, Samsung, simple clamshell phone here, works well. A Siemens phone, M35 I think, also worked perfectly well in the testing. An Alcatel phone, when Alcatel was still really Alcatel, also worked well. Two rather, let me keep them here, two recent GSM phones, also do 3G and a couple of other things, also work well. That's all fine. What didn't work, quite interestingly, is smartphones. I didn't get any smartphone to work. I tried a couple of Apple iPhones here. Got none of them to work with 2G. I also tried some Android phones. Doesn't work either. I'm not telling there's something wrong about these phones or something wrong about the CMU. Maybe I did something wrong in my testing. I still have to figure something out. But this is just to tell you that if you do testing, you might want to play around a little bit with phones and find one that actually works well, both in terms of registering to the network and setting up calls. It shouldn't be terribly difficult to find phones. There are plenty of phones around, so just go ahead and have fun. And a very final thing, should you want to do the same experiments as I did, for a while I was running into trouble, even the CMU hanging altogether when I was trying to do things like sending an SMS. I think I eventually figured it out. In this particular CMU, the computer battery, clock battery, is CMOS battery is empty. I still need to replace it one time. I didn't get to do that yet. As an effect, when it starts up with a BIOS with a kind of old date in there, and I think it is that old date with which the machine starts that actually makes something goes wrong, and it makes the machine crash in certain instances when doing stuff with SMS. After I've been like systematically setting the date manually each time I'm turning on the machine, everything runs fine. So I think is an issue related with the date of the machine. Now with that I come to the end of this episode. I hope you enjoyed it. I think I'm going to spend at least one more episode giving an overall verdict of the CMU200, and there's a lot of other interesting stuff that I'm still planning to do. So stay tuned. Goodbye.